Hello friends, Sumit this side from Trendy Tech. Now I am restarting my SQL playlist, which was a big hit that time. Now the first topic that I want to cover is CTE, Common Table Expression. Now, as I promised, I'll be coming with advanced concepts, and trust me, a lot of people get stuck with CTE because this is an advanced concept which does not come in basic concepts as such, right? So let us start to look what is CTE, what is the advantage, and how to use. Now, just to give you a context, you might have worked on subqueries, but writing subqueries can be a pain when we are writing complicated queries which involve a lot of nested subqueries, right? That is where CTE or common table expression can play a good role. So I'll write here and take it very slowly. So basically, the whole point to use CTE is to make sure we simplify the complex queries. So this is to simplify the complex queries, right? And now any query which involves the role of subqueries can be written as a CTE, right? In most of the cases. And that will be very much readable. So it improves the readability of a query. It improves the readability of a query, right? Now, with just theory, you might not understand. So I'll take an example side by side and then I will keep on talking about it. So let's consider we have a orders table. Select star from orders. Consider you have a orders table. I'll run this. And we have four columns. This orders table has four columns: order ID, order date, order customer ID, and order status. I'll write it. I have an orders table, right, with four columns: order ID, order date, and then we have order customer ID. Order customer ID is nothing but the customer who has purchased the order. So it's equivalent to customer ID as such. So order customer ID. So basically the customer ID who purchased this order, and order status. There can be various order status, whether order can be closed or pending, many things, right? Now, if you see in this table, order ID will be a primary key, unique, and order customer ID can repeat because a same person or same customer could have placed many orders, right? I mean, if you purchase on Amazon, will you purchase only once? No, you will purchase many times, and that's how you will place multiple orders, right? So, same way, there can be multiple customer IDs here. Now, what we want to find out as the very first thing is we want to find out customers who have placed. So basically I will rephrase this. I first want to find the total amount of orders each customer has placed. So total orders each customer has placed, right? This is the first thing that I want to find out, and based on this I want to find out all the customers who place the orders which are more than average of it. That means customers who order more. And how do we get to know? We will first find that, okay, how many total orders are placed by each customer. Then we will find the average of it. And people who are placing total orders which are greater than this average, we are looking to look at that. Those are like premium customers who are ordering more than others, right? Who are ordering more than the average which people order. So I hope I am able to communicate this well, that we want to find out people who places more orders. And how to do that? First, we will try to find out total number of orders placed by each customer, and then we will find the average orders given by each customer, right? And then people who are doing more than that are the premium ones because they are ordering more often. That's what I wanted to communicate. Okay. So now if I want to do this using my subqueries, how will I go about achieving this? How will I go about finding people who place more orders compared to others? Right? So I want to find out premium customers. And what's the definition of premium? Who places more orders, right? And how do we calculate? By just judging it with the average. If it is more than the average, it's premium, otherwise not. So initially the first solution 1 that I want to use here, I want to use a subquery approach. A subquery approach, that how to find this out. So what I will do is I will say select select order customer ID, this one, order customer ID, comma, right, count star. Count star. Do not judge me on this star now, because my intent is not to tell whether it is count star or count one or count some column. I am not teaching that, right? So select order customer ID, comma, count star from which table? Orders, where now group by order customer ID. If I do that, what I will get? And moreover, I will place some alias also here as total orders per customer. Total orders per customer. If I run this, what I am going to get? I am going to get that how many orders are placed by each customer. So it will give me total number of orders placed by each customer. So let me try running this. So if you can see, select order customer ID, comma, count star as total orders per customer from orders, group by order customer ID. I am grouping it based on order customer ID, so I should have it here and I should have one aggregate column, right? And we can get this. Let me run, and you can check here that customer whose ID is 2917 has placed 6 orders. Customer whose ID is 5834 has placed 4 orders, and so on. Some people would have placed 10 orders, 16 orders also, right? All of that. So what we have done till now is we have find out the total number of orders purchased by each customer. This is the first thing. Now, are we looking to find this? No, this was just an intermediary result. Our main goal was to find the average, right? The average amount, the average amount or the average number of orders placed by each customer is what we want to find out. So what I will say, select AVG average, and then what I have to give here, this column, select average total orders per customer, and I will give some alias name because this average will give me some field, right? I will give it as name as AVG orders per customer, right? From this, from this thing, and whatever I have placed in here, since I'm using SQL server, I have to give some alias name, right? A temporary name. I have given this. So if I run this, what should I get? What should I get? I should get the average number of orders placed by each customer. And I am using a subquery here, inner query here. You can see which is the inner query? This one. And what is the outer query? This one. So that means first the inner query is executed, then the outer query will be executed. Let me run this. Right? So I am able to find out the answer that on an average, each customer places 5 orders. This is what I have found out. Right? So, and I have used a subquery approach. So, solution 1 using subquery. Our final thing was different, that we want to find out premium customers who orders more than 5 times, which we will do later. But for now, let's try to have a problem statement that what is the average number of orders a person places. Average number of orders placed by each customer. Placed by each customer. And we have used a subquery approach to do that. Now, the title of this video is, what is the title? CTE, Common Table Expression, or we can say with clause. Now, I will show how to do this using a with clause or using CTE. The names are used interchangeably, so do not get confused. With clause or CTE means the same. Now solution 2 is using CTE or using with clause, whatever you want to say. Okay, let me see if video is getting recorded or not. Yes, it is. All good. Fine. So now I will talk about the syntax of CTE. What we have to do is, so basically whatever we have written inside, right, can go as a first statement. So we have to say with. So CTE starts with clause, as the name suggests, with also here, right? So with, what next we have to do? We have to give it some name, right? So we will give name, let's say total orders. With total orders, we'll place some column list here, do not worry, as, right, with total orders as, and here you will write your actual query. So whatever you have put it in the inner subquery, you can put it here. I'll put it here. Select order customer ID, right? Comma count star as total orders per customer from orders group by order customer ID. This is what I have here, right? And now ideally you can avoid this column names, but it's a good practice to give column names here. So I will give the same column names here. Select this comma total orders per customer. I will again repeat the syntax with, and then treat it like a temporary table, total orders, but it's not a temporary table. I will explain that later. But it's a alias for you to, when you want to refer this, how will you refer? So you have to give it a name, and this is that name. So with total orders and these two columns which are coming from the inside query, we will place it here. Good practice to do that. I'll talk more about this, but do not worry now. As, and then we write the actual query inside this brackets. Select order customer ID, comma count star as total orders per customer from this. So whatever was my inner query, I have made it as my with statement. Now, as I said, total orders is not a table. We will get results which are like temporary result set stored in memory, but not stored somewhere on disk and all. It's not an object in the SQL store. It is basically a result set held in memory for time being when we are running the query. Now we can use total orders as if it is an actual table. We can use that and get the results. So what we can do now, we can say select AVG, and we can say average uh, total orders per customer, okay, as, We can give a name as average orders per customer. Okay, from what is a table which you think of? Ideally not a table, but this is the thing. You can refer it this way. Select average of total orders per customer. That's what we have done earlier. Select average of this, right, from this. But in this case, since we have already named it as total orders, we can place. So basically, you think that in this query, this part is replaced by total orders. As simple as that. And after the with clause, the select should be the first statement. Select, insert, update or delete, anything we can use, but we generally use select as such. So it should be the first statement, otherwise it won't work. And you can have one statement only. It's not that after this select you write another select. It won't work. Only one select statement. And this entire query has to go together when it runs. It cannot be that you first run this and you are trying to run this later. No. When we run this entire thing, that time only the with clause is executed and the result of this is stored in memory as a temporary result set. It's not created as an object anywhere. It's not stored as such permanently anywhere, right? It's not a table, it's not a view, nothing. It's just a result set held in memory, materialized, right? And then we can refer it later in the immediate next statement. If you do not do that, it will give you an error, right? So let me first run this subquery, which we have already done, right? You can check this out. Average orders per customer is 5. Now let me try running this as well. And average orders per customer is 5. Exactly the same results we have got. But now, if you see, right now you might not see much difference because even this subquery is very simple. But the moment you talk about nested subqueries, a subquery inside another query inside that, a lot of these things, it will be very, very messy. It will become very, very complicated, and even you yourself will not be able to read the code if you read it after 2 days, right? That is where the beauty of CTE or the with clause is. It says that use this feature and try to write readable code so that 1 year later also if you come, you will say that wow, this is a clean code which I'm able to grab easily, right? Because if I see this statement by itself, it tells me just forget about with. If you just think of this select, it tells you very clearly select average from total orders per customer from total orders. That means we understood that we would have calculated total orders and then we can check how we have calculated. But if you see this as a whole, you won't get the complete perspective when you're checking the subquery thing, right? We will make this subquery complicated, then you yourself will realize that okay, it is significant readability gains that we get. I hope this is clear, right? I have executed it using both ways, subquery as well as the with clause. Now, generally, when we write subqueries, we tend to write something like query one, which is let's say the innermost, right? I'll increase the font, and then outside we write another query, query two, and then on top of it we might again write one more query, query three, right? This is how we write the subquery thing. And it can get really, really complicated because kind of we start reading it from here, then we have to understand what's the logic in query 2 and then what's the logic in query 1, right? Because we are used to read it from left to right, and the left query is just the wrapper query. It does not give us the complete perspective. Complete perspective we can get from CTE using the with clause, where the same thing would be written like query 1, and then finally query 2, and then query 3. This is how the flow of the CTE will be. So this is, I would say, subquery, right? And then this is the same thing. If we are doing using the CTE, it will be this way. Now you tell me which one is more readable. Definitely this one, because it's more of a logical, organized plan, step by step. So it's a linear step by step way that we interpret and write it, and which is very easy for us to grab. Fine. So now let's go one step ahead in this. What we will try to do is, till now we have calculated the average, I mean, number of orders placed by each customer. Now what I intend to do is, I want to find out all the customers who places more than this average quantity, or who places more than this average number of orders. The premium customers I want to find. So I want to find premium customers who places more orders than the average number of orders. What is the average number of orders? We have got 5, right? So who places more than 5 orders is what we want to get now. And the same thing we will try doing using the subqueries as well as CTE. And then you will truly say that this makes sense now. Let's see using subquery how to find that. So whatever we have used here or done here, let me quickly use that, right? So the inner query gets you the total number of orders. The outer query gets you the average number of orders, right? Now what should I do here? How do I proceed? So let me just quickly check what exactly we have done. Okay, and fine. So what we have to even do now is, we can say select star from, right? And then we can use this total orders query again. I'll explain you, do not worry. Let me first restructure this query little bit and then I'll explain you. Select star from, select order customer ID, count star as this, uh, group by order customer ID, and let me give it a name as, let's say, total orders. Okay, and then I'm saying join, select average, this thing, uh, okay, and then I will give a alias, I'll give the name here as average orders, just to be more meaningful. And then I will say on total orders, dot dot total orders per customer. Do not worry, I'll explain you if the query works, otherwise I'll rectify this query. Average orders dot average orders per customer. Okay, and this should be fine, I believe. Okay, let me try running this, and if there is any syntax issue I will rectify, and after that I'll explain you. Okay, incorrect this on, where is that? Join on total orders. Okay, okay, so you can see I have written a subquery approach to find this, and we are able to find total orders per customer 6, 9, 7, all of that, which is greater than 5. You can clearly see yourself. That means we are able to get the results using the subquery approach. And now let me explain you the subquery quickly. So what we have done is we we basically have written a subquery earlier or a query earlier which can give us the total orders, right? So you can see select star from, and then consider that you have two tables, total orders and average orders, right? And then basically you want to join these two tables on the total orders that are placed. So basically kind of you have to take it in a way that that basically your total orders which are there should be greater than average. That's what the condition we have placed on. It's not a equal to condition, it's a greater than condition, so that we only pick those orders from both the tables, right? So now if you see here, it's very straightforward, total orders and average orders which we have pre-calculated, but we have to perform a join here. You can just have a look. So select order customer ID, count star as total orders per customer, from orders group by this, total orders, and then average orders. So we have already pre-calculated that, we are using that statements again, but you can see this query here. And if I do a control F, you can see same thing we have to repeat here, right? Same thing, because when we found the average orders, we have to use total orders query, right? So this definitely has to be reused here. We cannot kind of reference this here again. So you can see there is a lot of duplication in the code, which makes developers life tough and more, make the code bulky, unnecessary. And apart from this would be creating a performance impact also, because it would have to calculate this again and again. This would run separately and this would run separately. If we would have calculated it one time and referred that, it would have been more performant, right? So you can see this becomes really a issue in this case. So all what we try to do logically is, we have total orders, we have average orders. All we want to say that, let's consider these are two different tables, although these are not directly tables that way. So we are saying, okay, give me all the orders, right? Where orders, I mean, the total orders are greater than average number of orders. And average number of orders, this will roll out to 5 actually. If you know, this will be amount which is 5, and we are getting the results this way. So now you can yourself sense that this is not a good way of writing, and it can really get very complicated. I have given line spaces and also it's looking easy again, but if you see, this is how it will be. And then if this is how it will be, then do you feel it's good? I do not see so, right? This is really not that great. If I give you this query, you will definitely take time to understand, oh, what's happening? I do not get it. So complicated. Now, same thing we will try to do using your common table expression, and let's see how to achieve that. So what we will do using common table expression is, we will say with, right, with, and we will say total order. See, it's a three-step process. In whatever we are doing is a three-step process for the query we are writing. Number one, we calculate total orders. Calculate total orders per customer. Number two, calculate average number of orders for each, for the customers. And the third thing, and what's the third thing? Third thing is, again, get to know the customers who are premium. Get to know the customers who are premium. And definition of premium is people who purchase more than the average times. Okay. So it's a three-step process. Now, when we see this query, you won't relate that, okay, we are doing logically this way because it's complicated using subqueries. Now, with CTE approach, it gets super easy. So we will say with, and whatever we have to calculate first, we will calculate logically. So we will say with, and then I will give it a name as total orders. I can give any name, but good to give a more meaningful name. And then I'll give a list of columns. I am keeping it blank for now as, and I will give a query here. And that query is to calculate total orders per customer. What's that query? I'll take it from here, this one. So select order customer ID, comma count star, group by this. So this will give me total orders per customer, right? And then I will give the same list of columns here as a good practice, comma total orders per customer. This is my first step that is done. I hope this is clear. If I say select star from total orders, I should get this result. Select star from total orders, then I should be able to see these results. Let me check that. I'll come here, I'll run this, and we can see I'm able to get total orders placed by each customer. Now, step one is done, right? Now, let me extend it further. I do not want to use this here because my intention is not to calculate total orders by customer. That was just one intermediary step. I have given a comma and I can write more of with statements here. It's not that just one temporary result set we can have, we can create more to make it easy. But you won't be using with keyword again. You just give a comma and then name of the other result set. It will be average orders. If you see, first calculate total orders and then second is calculate average orders from the total orders created. So I will say average orders, okay, and then what I have to give the name here, I will give later as, here what query I have to write. How do I calculate average orders? I'll go up and then I'll take this query, select, or I'll write it only, no problem, because it's a small query that I have to write. Select AVG average of what we want to get, average of total orders per customer, right? Select average of this as AVG orders per customer, okay, from total orders. I'm using this result set now, total orders. You can check this, right? I'm using this result set. Quite easy to understand. You can check this out. So first temporary result set and then we are creating second temporary result set. I'll give this same name, sorry, this name here. I can avoid it also, but it's best to give so that it becomes more readable. And then I can say here select star from average orders. So you can see we use step 1 and step 1's result is used in step 2 and then finally step 2 whatever result we are getting we are printing it. So it is in a sequential fashion we are writing top to bottom, makes life easy. And we can see there are total 5 average orders placed by each customer. All good. Now my intent is not even to do this, I want to go beyond, right? So what I have to do now, the select query, see the temporary result set that I have to create, these two are enough for me, but my query requires a small join because I have to join this average orders and total orders in order to get the results, because then only I'll be able to compare the total orders, this thing, total orders per customer with average orders per customer. How do I compare these two columns? These two columns are spanning across two tables. That's why I require a join, a simple join. So let's do that. Select star from, right? Select star from, what is this? Total orders. Consider both of them are tables. Ideally it is not, but consider both are tables and work with them that way. Join average orders on, okay, total orders. So we have to tell what's the criteria on total orders dot total orders per customer greater than average orders dot average orders per customer. As simple as that. And trust me, when I was writing subquery, I also got confused for a moment, right? And with this, in CTE, it becomes super easy that the control is in our hand. We won't deviate. It's a very, very logical approach that we said, okay, first we found out total orders, by each customer. Then we found average orders by each customer. Then we are doing a join on these two result sets. So easy, super, super easy, right? And I will run this. I should get the same answer. Let me just try showing you. Hopefully we do not get syntax error, and we can get, or we are getting the same answer. But which one is more easy to interpret, you can yourself understand. One is this query, which is through subquery, and one is this with the with clause, right? So with this, I have explained you practically that we follow a step by step linear approach when we are writing CTE. But when we are writing subquery, it's a very different approach, and the human brain cannot interpret it actually. So the most important aspect why we use CTE or the with clause is to make it more readable and the query gets simplified. Performance gains and all, I'll talk now, but it's not truly that we think we will get huge performance. In this query, whatever we are writing, definitely it will be more performant also, because the same subquery we are repeating multiple times. If you see this one, right? This one, you can check that we are writing, sorry, here we are writing it two times exactly. And when this subquery goes more and more nested, definitely all this redundancy will increase only. So not recommended, right? So let's discuss more theory about CTE. We have seen practically, and now the theory will be a cakewalk for you. So CTE defines a temporary result set that you refer within another select, insert, update, or delete statement immediately following the CTE. What do I mean by immediately following the CTE? If I do not give it here, then it won't work. If you think that we can just run this, it won't run. Let me show you. If I just run this, it won't run, right? And moreover, if I give two select statements, for example, before this, if I have select star from orders, right, it might fetch results for this, but after that it will fail because it will not understand what is this total orders and what is this average orders. It won't understand. I'll show you. If I run this, it might show you some intermediate results, but after that for this line it won't identify total orders and average orders, right? You saw the result sets, that means this line worked, but when it comes here it won't be able to recognize, because we can only use it in the next immediate line, then only it can recognize, otherwise not. I hope this would have made some sense actually. So I will write it here. CTE defines a temporary result set that you can refer in select, Just like we are using select, you could have used insert also, you could have used update also, you could have used delete also, statements, right? Immediately that follows as CTE. Immediately follows the CTE. If you do it later, it won't work. I hope this is clear to you. If I remove this line and if I run this, it will work. I hope this would have made sense. Okay. Now CTE is not stored in database as an object. It is a temporary thing held in memory, and very temporary. I mean, this scope is only defined for this. That means it gets calculated, and then once we are done with the query, it's all lost, right? So it's hold in memory. There is no object that is getting created. Also, one more thing, what is the role of this columns? Do we really have to put these columns? I said it's a good practice, but do we really have to put? See, in this case, in our case, we can eliminate this, right? I'll show that. For example, I can eliminate this, let's say, and it should ideally work fine, right? So, what is the whole purpose? Why should we put? See, I'll tell you, sometimes what happens when we are doing a join on two tables, might be same column name is coming from two tables. That time, when the column names are not distinct, then we have to tell what columns we have to use, right? Then we have to tell what columns we have to use, or we have to give it a different name. For example, I'll show that. I'll make a copy of it, right? I'll take a copy and I'll show you some things. For example, I say order customer ID once again here, order customer ID, right? Comma this. I'm using this column name two times. Consider it's coming from two different tables. Let's say we have done a join and all. Now, one thing is that if here we have three columns now, and here we have two, definitely it will fail. I'll show you that first of all. We have to remove this line. Okay, it will fail. Total orders has more columns than that were specified. And the other way is also that if you remove both of this and have two here, then also it will fail. So the number of columns should match if you are giving that, first of all. So if you are having this, then number of columns should match, exactly match, number one. And if there are two different columns here, then what we have to do, we cannot even remove this. If we remove it, it will say there are duplicate column names. In this case, it becomes mandatory to have this here. I'll show that. The column order customer ID was specified multiple times for total orders, right? So in such a scenario, when we do not have distinct column names coming out, we have to put this. And here we can give a different name. For example, let's say order customer ID and then order customer ID 1, we can say. Because if I again give the same, it won't take. And then finally, total orders per customer. What I am saying is, first of all, it's a good practice to give this column names here. And in case if the values coming are not distinct, then it becomes mandatory to give. And the number of columns should exactly match, right? So now I will run this and show you that whether this is working or not. I'll remove this select star from orders here. And let's see. And we can see this is working all fine. So I hope you would have understood what's the role of these columns here. Ideally, good practice to give, but not required always. But when it is required is when the columns that you are getting from here might not be distinct and will be repeated. So that's where you have to definitely give this and give some other alias name so that the system takes it. And this number of columns downside and here should exactly match. If there is a mismatch, it will again give an error. I hope this is fine. Now, talking about performance, a lot of people say CTE improve the performance, right? People say CTE improve the performance. Yes, it can, but only in some cases. CTE can improve the performance, but not always. Sometimes it might degrade the performance, right? Now it depends on the database implementation that is there internally. Might be Postgres has a different implementation, MySQL will have a different implementation, Oracle will have a different implementation. It depends on database to database also. But nowadays databases are smart. They are saying better you do not think about optimization, you write your query because it's giving you more of simplification or more easy way of writing or readable code, and I will try to make sure that your performance is not getting hurt. Generally databases are coming in that mode to do that, right? For example, in what scenarios CTEs can give performance, right? So CTEs have been originally implemented with an optimization intent, if you ask me, right? Kind of, we are telling system that okay, I am writing this query, do materialize it and keep the results in memory, which I can refer through this name because I will be reusing it again and again. So, with a very positive intent, we have said, please calculate these results and keep in memory because I'll be reusing these results for performance gains. Right? So, in such scenarios, when we are reusing things again and again, just like in our purpose, it will give performance benefits. But in some scenarios, it can degrade the performance also. What can be the aspect where it degrades the performance? Let me tell you. For example, I will talk about Postgres implementation. Postgres, right? So basically, Postgres SQL, right? Here, before version 12 of Postgres, the implementation was in a way. For example, let's say you have select star from orders, right? This is a query that you have. Now, if you write a CTE on top of it, just for the namesake, let's say you say with orders CTE as select star from orders. Select star from orders. Let's say here we have where order ID equal to 10,000. Now we are saying with order CTE as select star from orders, and here we are saying select star from orders CTE where order ID equal to 10,000. Now, since I am using MySQL implementation, I will show you here there is not a no problem. If I run this query, right, and I right click here, say command palette and run query with actual plan. If I run this and I see, you see that estimated cost 100 and it has gone for clustered index seek. That means some indexing is working. That means we do not have to search one by one. It's quickly searching it and it took very less time to have this 0.047. Now, same way, if we are using this CTE with order CTE as this and select star from order CTE where this thing, how much time will it take? It will take roughly the same time, right? If I show you 0.028, almost the same time, and if I open command palette and run with this thing, I still see same clustered index seek coming into play. But now think it this way, if truly it is materializing it, ideally in this case it is not materializing, I will tell you why. If truly if it would have materialized, what it would have done is it would have taken all these rows and put it to this order CTE temporary result set in memory. And then from that, it would have again searched for order ID 10,000. And trust me, on CTE, right, the indexing does not work properly. So the indexes are not performant. That means even though when we are searching this, it might have looked entire thing. So it would have done two scans. One is when putting all this data to order CTE first in memory, all the records, and then searching all the records all the way to find this number 10,000, because indexing would not have worked fine. So if ideally this would have materialized, that means if this would have been calculated and stored into this, it would have taken a lot of time. But in this case it's not happening, because system is smart enough and it would be not doing that. So system is taking a call whether should I materialize this or not. In this case it do not feel that materialization will benefit, so system has not done. If you ask me, in Postgres SQL before version 12, it would have definitely materialized it, and it would have taken a lot of time. So I'm saying it sometimes depends on database implementation, that what they do. Right now you are mostly using CTE or with clause for your, I mean, readability gains, not for performance gains. Performance can get degraded, but systems are smart enough now. They say that do not worry, you just think about your readability. I'll take care of performance. If I feel I should materialize it, I will. If I feel I should not, then I will not. I hope in this scenario you understood that definitely this is not getting materialized. If it is, then it would have taken a lot more time. So as I said before, version 12 in Postgres, right? If I would have done this, it would have taken a lot of time. But now, after or from 12th version of Postgres, right, or even in Oracle, there is a concept that it will not materialize all things. It will judge whether it should do or not. But still, if as a developer you say that no, I have written my code, I want this to be materialized, then there are hints that you can say materialize or not materialize, and it will do that way, right? So from version 12 there is a concept of system taking care by itself. But if we want to hard, I mean, force it on the system that no, you do not judge by yourself, I am saying that it has to be materialized, then a hint could have been given in version 12 and beyond, right? So basically now systems are smart and they are doing it inline kind of. What they would have done is they would have written the same query here actually, right? So systems are putting it inline. That means when they feel that okay, CTE would have degraded the performance, they are not materializing it, and system is kind of putting it inline. That means the same definition it will keep here, but from our side we won't see that. We will get the same performance as we would have got with subquery. So as I said, many people think that CTEs give better performance. It can in certain scenarios when we are like doing a lot of repetition of code. But it can backfire also, where it can degrade the performance heavily by doing materialization of queries or tables, and indexing won't work. Moreover, materialization also takes time, right? It has to do one full scan, all of that, because all the other optimizations will go for a toss. So more than helping us in optimization, it kinds of backfires in optimization. That is where systems are more intelligent to understand whether they should materialize it or not. I think I have talked about it gracefully. This is quite important to know, and very much important. All the systems would be working on those directions now, ideally. I hope with this we have covered CTE in a good amount of depth. I have tried my best to convey the things in the right manner. If you have liked this video, then hit the like button. Do mention what new topics you want me to bring next. And trust me, CTE I want to cover a little more by having more examples. What I would do next is I'll have some lead code examples which I will try to solve using CTE instead of subqueries, so that you get more comfortable with it. The moment you understood CTE, right, you will be trying to solve almost all the problems with that, all the complicated problems with that. That will save a lot of time, that will be much more readable, and it will look very, very graceful also, right? So, if you have not yet subscribed to my channel, do subscribe now. I will be bringing the best top notch content in SQL. I promise that, and I hope you would have liked the video. And do mention in comments what are your thoughts. Thanks a lot. I'll stop the recording. Enjoy.